In this tutorial, we are going to explain the meaning of coroutine, suspend functions, and creating a coroutine, dispatchers, structured concurrency, and finally using a coroutine in Android Jet Campus project. Kotlin coroutines. Coroutines allow the execution of block of code to be suspended and then resumed later, so that other work can be done in the meantime. Coroutines help to manage long-running tasks that might block the main thread. Suspending functions. The keyword suspend is Kotlin's way of marking a function or function type available to coroutine. When a coroutine calls a function marked suspend, instead of blocking until the function returns, like a normal function call, it suspends executions until the result is ready. Then it resumes where it left off with the result. While it is suspended waiting for a result, it unblocks the thread that it's running on so other functions or coroutines can run. In this example, we have data fetch suspend function with coroutine run in output input output thread and a network request suspend function run in our main thread. Network request suspend function, instead of blocking main thread, it suspends execution until the result is ready, then it resumes where it left off with the result. While it's suspended, waiting for a result, other functions like draw can, can run and other coroutine. Data fetch suspend function with coroutine run in input output thread, making our main thread safe. After execution, it returns the result to main thread and shows data in our app UI. Creating a new coroutine. There are two ways to create coroutines: launch and async. Launch will create a new coroutine that is fire and forget. That means it will not return the result to the caller. Async will return the result with a suspend function called await. In most cases, we used launch method for creating coroutines. Create a coroutine in the view model. When integrating coroutines with Android components, you typically want to launch coroutines in the view model. To use coroutines in a view model, we use view model scope extension. Here, in our example, we use launch method for creating coroutine, and you can think of launch as a bridge that takes your code from regular function into coroutine function. Inside the launch, we can call suspend function, and we also use view model scope for cancel any coroutine that is started by view model when it is cleared. Dispatchers. Kotlin provides three dispatchers to specify where the coroutines should run: dispatchers.main and dispatchers.io and dispatchers.default. Dispatchers.main mean main thread on Android interact with the UI and perform light work like calling suspend functions, call UI functions, and update live data. Dispatcher.io optimized for disk and network I/O, like reading and writing files, networking data requests. Dispatchers.default optimized for CPU intensive work like sorting a list and parsing JSON. As mentioned before, dispatchers specify where the coroutines should run. So we should note that for room, will make your query main save and execute it on a background thread automatically. And for network libraries like Retrofit and Volley, manage their own thread when used with Kotlin Coroutine. Structured concurrency. A leaked coroutine can waste memory, CPU, or disk. To avoid leaking coroutines, Kotlin introduced structured concurrency. Use structured concurrency to cancel coroutines when it is no longer needed. Keep track of coroutines and signal errors when a coroutine fails. To ensure that all coroutines are tracked, Kotlin doesn't allow you to start a new coroutine without a coroutine scope. A coroutine scope keeps track of all your coroutines and it can cancel all of the coroutines. Launching new coroutines everywhere creates potential work leaks. Structured concurrency provides a guarantee that when a suspend function returns, all its work is done. For example, using coroutine scope to fetch two documents as shown, fetch document 1, fetch document 2. The coroutine scope builder will suspend itself until all coroutines started inside of it are complete. In coroutines, errors are signaled by throwing exceptions, just like regular functions. Exceptions from a suspend function will be rethrown to the caller by resume. Structured concurrency guarantees that when a coroutine fails, its caller or scope is notified. In this example, we are going to get data from a remote web server using network request, and we will simulate the network request by adding delay suspend function as shown in our main view model. We are going to use delay with 2 seconds. As shown by pressing the load button, we sending a network request and getting string word every 2 seconds using on-click function called loading data in our main view. Inside our loading data function, we create a coroutine with launch function and using view model scope as a structured concurrency, and we calling delay suspend functions with